before going to the passive elements, we have to study Ohm's law. Ohm's law. Okay. So what is Ohm's law? What is meant by Ohm's law? As I am taking a conductor, conductor consisting of a resistance. This is a symbol of a resistance. This is a symbol of a resistor. Resistor is a two-terminal element. Resistor is a two-terminal element, 1 and 1 dash. So the symbol is represented, which is denoted as R. Resistance is a property of a resistor which opposes the flow of free electrons. See, resistance is a property of a resistor which opposes the flow of free electrons or electric current. Okay, resistor inti. What is mean by resistor? It is a two-terminal device. Okay. Now, coming to the Ohm's law. So here I am applying a supply voltage is V. Then obviously current is flowing through a resistor. So the voltage produces across a resistor. Suppose if you take a bulb, one bulb, so that is a tungsten filament bulb, which is the best example for the resistive load. Sir, what is meant by source and load, sir? Source means it delivers the energy. Load means it consumes the energy. So if a bulb is there, or water heater, if you take a water heater, what it will do? It will dissipate the energy in the form of heat. So that heat is utilized to heat the water. That is the best example for the resistive load. Load means consumes the energy, right? So always the current flows from higher potential to lower potential. Higher potential is represented with plus here. Higher potential is represented with plus, lower potential is represented with minus. Always the current flows from higher potential to lower potential. And the volt which will produces a drop here, the voltage drop across a resistor or conductor, which is directly proportional to I at constant temperature. Then this law is called the Ohm's law. Ohm's law is V is directly proportional to I. So if you take a conductor also, and the current is passed here, if a voltage is given, current is flowing through conductor, which will produce a drop, and V is directly proportional to I at constant temperature. We can define one constant value that is equal to resistance. Resistor element, resistance is the property of resistor where V is equal to IR. So just now we have taken one formula where I is equal to V by R. I is equal, from this we can write it as I is equal to V by R. So what are the limitations of Ohm's law? See, observe that. Why I am calling as a resistor is a linear element means if you vary the voltage, the current is also varies linearly. If you vary the voltage, the current is also varies linearly. A straight line passes through the origin. That's why resistor is a linear element. Similarly, L, C are the best examples of the linear element. Okay, so now resistor is a two-terminal element. What is R, L, C? What is R, L, C here? Tell me. Which comes under the category of what? Passive elements. See, passive elements are R, L, C. So this part is over. The active elements, voltage source and current source are independent and dependent in this independent ideal voltage source, ideal current source, practical voltage source and practical current source all are over, and dependent sources are also over. And the next classification is called the passive elements. The first element in a passive element is called the resistor. So what is a resistor? Resistor is a two-terminal element. Resistance is a property of a resistor which opposes the flow of free electrons. So how it opposes, sir? How it is opposes? How the opposition will be produced? How the opposition will be produced? So if we take a conductor, what will happen? Conductor which is made up of a copper consisting of so many molecules, and molecules, it is a inbuilt of atoms and compounds. And as I am applying a voltage source here, what will happen? Electrons are moves towards the, electrons is having a negative charge, electrons moves towards the positive terminal of the supply. During this process, what will happen? Electron moves in this direction. Okay, the what is meant by electrons? The valence electrons which are loosely attached to the center of the atom. So if it is an atom is there, so these are called the valence electrons. These are called the valence electrons which are loosely attached to the center of the atom. This is called the nucleus. So this is called the valence electrons or free electrons. So during this journey, what will happen? It will consisting of so many atoms. It will hit the one more atom. It will hit the one more atom. It will release the one more electron. It will hit the one more atom, it will release as one more electron. So when a straight road is there, you have to move very faster rate. But once electron will be hit the atom, then electron speed will be decreases, right? And one more electron will be produced, and it will hit the another atom. Whatever the speed of the electron will be reduces. So that concept can be taken as a resistance or a resistor element, which that is represented with R. So what is the first element here? First element is a resistor. So this is a passive elements. See, now in this passive elements, resistance is directly proportional to what? So resistance is directly proportional to what? So resistance is directly proportional to length of the conductor. Suppose as I am taking a 1 centimeter wire is 1 ohm, and another 1 centimeter wire is having a 1 ohm. If you are connected like this, what will happen? What is the length of this one? Is 2 centimeter. So what is the resistance now? 2 ohms. Resistance is directly proportional to length of the conductor. As the length of the conductor increases, and the resistance value is also increases. Suppose if your area is increased, what will happen? Let us say this is 1 ohm and 1 ohm area. So I think you have an idea. Two resistors are connected in parallel. R1 R2 by R1 plus R2. You have to take a parallel combination. 1 into 1 by 1 plus 1. 1 by 2 is equal to 0.5 ohms. We will discuss how we can get the R1 R2 by R1 plus R2 if two resistors are connected in parallel. So 0.5 ohms, which is less than 1 ohm. See, originally it is 1 ohm only, but resultant you are getting 0.5. So that's why resistance is inversely proportional to cross sectional area of the conductor, and the resistance is equal to rho L by A, where rho is called the resistivity, and the units of a resistance is called the ohm. Symbol is like this, and which is measured in ohm. Okay, and the resistivity is rho is equal to RA by L. So ohm, area units are meter square, length units are meter. This is very important. Units of resistivity is very important in an objective bit. Resistivity units are ohm meter, resistance units are ohm. Okay, so what is the V formula? So what is the V formula? Where V is equal to IR and I is equal to V by R. And what is the power formula? Electric power. So this is also very important. Electric power. The rate at which work is done is called the electric power. So what is my electric potential? Recollect the data where V is equal to dW by dQ. dw by dq. You can write it as dw by dq into dq by dt multiplied divided with dq and multiplied with dq. So what is I? I is equal to dq by dt. I is equal to dq by dt. And so dw by dq is called the v and dq by dt is called the I, where the power is equal to, it is a product of voltage into current. It is a product of voltage into current. Okay, so I think electric potential is the rate at which work is done. Yes, the ability of charged body to do the work is called the ability of charged body to do the work is called the electric potential. Okay, it is not dw by dt, it is dw by dq, and where I is equal to dq by dt and the electric power is equal to v into I. What is the power is equal to v into I? Substitute IR value, IR into I, that should be equal to I square R. Throughout BW subject, I square R we can call it as power loss. I square R is call it as a power loss. Okay, and one more thing, I is equal to v by r, you can substitute here v square by r, v square by r. Why? Because I is equal to v by r into v, so that is v square by r. Okay, so power loss, and also we can call it as a copper loss. Okay, throughout PW subject you have to remember power loss is equal to I square r, or also called as a copper loss. Now this is about the first element, and next one is heat or energy. Heat or energy. So power consumed multiplied with time. Power consumed multiplied with time, then we can call it as a heat or energy. So heat is equal to, what is the power consumed? Power loss or power consumed, both are same. So I square RT. The units are joules. The power units are watt. Power units are watt. Okay. So the best example for the resistive element, resistive load is called the water heater. If you are insert a water heater in a water for 5 minutes, the temperature of the water, let us assume it is 40 degrees centigrade. And if you are kept more time, if you are immersed in a more time, so that is 10 minutes, up to 10 minutes, what will happen? The temperature of the water will be increases. As the temperature of the water will be increases, then the heat which is produced is also increases. The property of a resistor, one more important property, it always dissipates the energy. It always dissipates the energy. Dissipates the energy in the form of heat. It always dissipates the energy in the form of heat. This is the second property of a resistor.